Okay, you look at it, this is question number 1. Basically, it's a merge sort. Merge sort, before you do it, you have to, because we have applied this algo to an array of elements there. Yeah, so let's look at the key principles of this merge sort. So A is the array. So later on, we will see that this one will be the array. We are going to do the sorting. I is the starting index. Yeah. So you start from 1, I will be from 1. But it will be changing, yeah, because sometimes we only look at a small set of it. Yeah. So I will change, and the J will be the endpoint of that. Yeah. At the very beginning, the first one is here, this element, and this is the last one here. So this one, the index of this one will be I, the index of 16 will be J, and so on. Okay, so it has some base case, yeah, because it's a recursive algo. The base case is like this. If I and J are equal, I and J equal, that means you have only one element. Do you need to do the sorting? No need to do the sorting, but at least at the very beginning, you have to look at the element. Oh, we have I and equal, I and J are equal, so we don't need to do it. We just return it. Yeah, no need to do anything. No need to sort. You have only one guy here. All right. So if they are not, what we should do? We have to subdivide it into two parts. Yeah, almost equal. So we have to find the endpoint. The endpoint will be I plus J. You add them together, divide by 2. So this one we use the integer division. Don't give me something like 5.5 or 2.5 or all this integer. Okay, so M should be the midpoint because it's the index of one of the element here. So it cannot be 2.5 or 3.4 or 4, something like that. It must be in integer form. Okay, so once we divide into 2 parts, the first part will be from the I up to M, because we divide into 2 parts, right? We chop it into 2 parts. The first part, the index will be from I up to M. So we will pass it to it. We use the recursive algo here. You see that they are the same name here. But the index, the index of I may change, the same, but the next one, J, will change. The endpoint will be M. M will be the midpoint. So up to the midpoint, it will be passed to this algo here, merge sort. The next part is from M plus 1 up to J, will pass to another one. So this one is a recursive algo. It will go back to this one to iterate again and again, something like that. But when we understand this algo, so we don't go to the detail. Later on, we'll see that actually we go to this one again and again. So you ask it, you pass to this merge sort, it will help you solve the problem, sort it from I up to M. Then the other one also you will sort it. So after you have 2 sub-array, they are sorted already. So what you do? You have to merge them together. So you call another one merge to sort them. I up to M will be the first algo. The second algo, the second subarray, the first array will be from I up to M. The second one will be M plus 1 up to J. Okay, so the algo is very, very simple, right? You have an array, you chop it into 2 parts. Yeah. So you sort the first part and you sort the second part. You combine them together. So you also need to specify the base case. Base case is I and J are equal. If they are equal, you have only one element. No need to do anything, just return. All right? So very simple. Okay or not? So once you understand it, we'll apply this algo to this array here. It has 10 elements here, right? 10 elements here. So let's see how do we do it. Yeah. Now, first of all, we have to sort this one. We call the merge sort. This is an array from 1 up to 10, because the I is equal to 1, the first index, right? The last one is 10. So it's from 1 up to 10. So we are going to sort this one. So it will not go to the base case, right? Because I and j are not equal. So you will go to here to find the midpoint of that using integer division. So we will do it. The integer division gives you the result 5, because 1 plus 10 divided by 2 is not 5.5. Don't use your calculator. Don't use your calculator. Use this one here. Okay, 5. Then you merge it from 1 up to 5. You merge it according to this one. You merge it from 1 up to m. M is equal to 5. Is it okay, this one? Any questions? Okay, so now our focus will be from 1 up to m, these 5 elements here. The others are darkened. I use gray color, means our focus will not be on that. Any question first? Yeah. Any questions? Yeah, please. Any questions? Any questions? Any questions? I cannot hear. Yeah. Can you speak louder? Sorry, yeah. So I find that you say when I mark the paper, your quiz paper, I found that you sometimes you cannot catch what I mean. Yeah. Some keywords you overlook that, or maybe you are using fast forward very fast, 2 times, 3 times, yeah, cannot hear it. Yeah. So many key things you are missing. Yeah. Okay, so we are focusing on this 5. You look at it, 5 only. Then the other one we don't care. So we will call this one again. So we'll pass it. Then we'll start this again. So I will check whether 1 and 5 are they equal. They are not equal, right? So the base case will not happen. We will go to find the new m, the middle point here. The midpoint will be 3 in this case here. Will be 3. So you have 5 elements. You chop it into 2 parts. 3 plus 2. But now the focus will be on the first 3. So now we will do the merge sort from A from 1 to 3. 3 elements here. Okay, so we'll check it whether they are equal or not. They are not equal, right? 1 and 3. So you will not execute the base case. You go to the merge sort from 1 to 3. So 1 to 3, you also chop it into 2 parts. So the first part will be 2 elements. The last part will 1 element, right? So we focus on the first part, 2 elements here. Is okay? We keep doing that, chop it into 2 parts, chop it into 2 parts, chop it into 2 parts, until later on you see that you have only 1 element. You will execute the base case and you will go back. Up to now, okay or not? And now we'll do the merge sort from 1, because we are still stuck here. You look at it, we use the merge sort from this one to this. Yeah. We never execute the next one. So we are here. We are here. Once we come to here, we hit it. Oh yeah, we have to go back and hit it. We have to go back. We hit it a few times, right? So you will see that. So the next On the next page, we will see almost we will go to the end. Now, so here we divide, you have two elements, we divide into two. So the midpoint will be 1. So the rest will be 1. So you have one element, right? On each sub array. So it will fit the one element will fit the base case here. You are doing from 1 up to 1, right? You look at it, you have two elements. You chop it into two parts. The first one, you have only one element. So we'll focus on the first one here. You have only one element. Do you need to sort it? No need to sort it. You just return it. You just return it, and you have another one element, number 2, right? So you also do the merge sort, but because it fits the base case, no need to do anything. So now you have 11 and 29 in front of you. So you have to, so the first one here is from 1 up to 1 is here. Then the next one is from 2 up to 2. So now we come to here, the second merge sort. Once we finish it, we go to merge. Merge the first element and the second element. So the smaller one we'll put here, but it happened we have only two elements, 11 and 29. 11 is the smaller one, you put it as the first one, the second one is 29. So we finish it. Okay or not? It's very tedious, not as smart as you, but you have to understand it, yeah? Okay or not? We finished two elements. But you see, you have to ask yourself, where are you from? You at that time, the previous step is you have 3 elements, right? You have 3 elements. You chop it into 2, you have 2 plus 1. So you finish the 2, you still have 1 here. So you have to go back to finish the most recent ones, right? So we have to come to here to finish the most recent one. So the reason one, you have only 1 element, because at that time we have 3 elements, right? We finished the first 2. Now we still have the third element. The third element is our focus here. So we will call the merge sort again. But this one is from 3 to 3, only 1 element. We don't need to do anything. The base case, right? Once it's base case, then we can merge them together. Because we have 2 elements and 1 element, we will come to here, finish this one from 3 to 3. Now we come to here to merge them together. So when we merge them together, we'll get something like that. The smaller one will be here and merge, right? Yeah, so it's 28 and the largest one will be there. So these 3 elements here are okay, are sorted. Okay or not? Okay or not? This one. So now you have to say that what's the most recent operation we have not done. At that time, we have 5 elements. We chop it into 2 parts, 3 elements plus 2 elements, right? That one we have not solved it. Because we solved the 3 elements. The next 2 elements, we haven't done that. So we have to go back to take care of that 2 elements, right? We have 5 elements. We say that, oh, we chop it into 2 parts, is 3 plus 2. Then we keep doing the left-hand side, right? The right-hand side, you still have 2 here. So now you have to go back to understand it, yeah, to look at these 2 elements here. So our focus will be these 2 elements. Okay, so it's 4 and 5. So this yellow one will be the one we are focusing on. Okay or not? So now we chop it into 2 parts, the 4th element and the 5th element. On the next page. On the next page, we use the midpoint because 4 and 5, the midpoint is 4. So you have the 4 and 4, right? Merge sort, no need to do anything. 5 and 5 is the other one, no need to do anything. So later on, we combine them together, merge them together. The smaller one will be put here, and the bigger one will be here. So it's 23 and 20, but because the merge, the smaller one will go first, and the bigger one will be the last one. So now we finish this one. So you have 3 and 2. So now you have to combine them together. So you have to merge. So you merge from 1 to 3 and then up to 5. So the first group is 3 elements. The second group, 2 elements. You merge them together, the smallest one here, the largest one at the end. So these 5 we have finished. Okay. So it's a little bit tedious, yeah, because this computer is a very dumb one, you say. So he will do it, but he can do very fast, yeah. So you have to buy it, yeah. So okay, this one 5. Now we then you ask yourself, so where should we go? You have to remember that the most recent one, you have 10 elements, you chop it into 2 parts. We have the first 5 and the next 5, correct? So you have to take care of the next 5 on the right hand side. So you have to merge sort from 6 up to 10. The yellow part will be the last 5 elements here. So you still do the same thing, chop it into 2 parts, 3 plus 2, take care of the first 3, become 2 and 1, and then keep doing that exactly the same style, right? No difference. You have the first 5 elements, you have the last 5 elements, right? So the last 5 elements, you will do exactly the same as what we have done for the first 5. So I will do it a little bit fast. So we'll take care of this 5, and then we find the midpoint. Then you see that the focus will be on the first 3, and then the last 2 we don't care at this point. So once you have 3 elements, you chop it into 2 parts, 2 plus 1. 2 plus 1, so you take care of the 2 first. 14 and 5. Then you see that you have to divide it into 2 parts. One is 14, one is 5. So you merge sort 1 element each of them. And then you merge them together. So 5 will go first, and then 14 will be next. So for these 2 elements, you have finished it. Yeah. But at that time, you have 3 elements, right? You go back to take care of this one, 5. So this 5 here, this third element and these 2 elements, we have to combine them together. So like that, we merge sort from 8 to from 8 to 8. It's not 7 to 7. Oh yeah, this one merged to 7 to 7. This one finished. Oh yeah, now it's 8. Yeah, number 3. So number 3, we don't need to do it because 8 to 8 base case. Now you have 2 elements and 1 element. You combine them together, then you settle these 3 elements. Okay, so once you settle, then you take care of the last 2. The last 2, you find the midpoint, and then do the merge sort of each one. But it's the base case, right? Each one of them. Then you merge them together. So the 15 and 16 settle. So now you have to take care of these 3 elements and these 2 elements. So you do the merge them together. So this 5 is okay. This 5 is okay. And previously this 5 is okay, right? The first 5 is okay. Now the last 5 is okay. We have to combine them together. So you have to merge the first half and the second half. And this one will be the answer. So a little bit lengthy, but it's a good exercise to understand how the computer do this kind of merge sort, right? And probably you will do the same thing. You can do the same thing. Don't just look at it. Yeah, you have to chop it into 2 parts. So you can draw some diagram to help you. At the very beginning, you have 10 elements. You put it into 2 parts. the left-hand side 5 elements, the right-hand side 5 elements. You focus on the left-hand side, the 5 elements will be subdivided into 3 plus 2. Then you take care of the 3 elements, you subdivide into 2 plus 1 and so on. You see the tree will be like that. So at the end, you finish it, you go back until you can merge them together. All the 10 elements will be in the correct position. Huh? Okay or not? I can let you see the answer, but we go to the details, right? We draw the diagram and let you see each step here. So when we understand it, yeah, so we'll just look at it. Oh, the first part, we do the sorting. We finish it. The second part, we do the sorting. We finish it, and then you merge them together. This is how we understand it. But actually, we have to go to from 10 elements into 5 elements, from 5 elements into 3 elements, and so on. So at the end, you will use the base case to terminate. Yeah. Right? Okay, any questions from you? Online student, how about? So it's very important. So you have to understand it. The merge, how do you do it recursively? So actually we are using the same algo, but we make the number of elements smaller and smaller and smaller until it is the base case. Oh, the base case, we are very happy, we can go back. But you have to remember the most recent one. So you have to draw a tree to know that once you finish it, you go to the previous level. Don't remember that, don't think that you always remember. You have to draw something to help you. From 10 elements into 5 plus 5. From 5 is 3 plus 2. 3 elements is 2 plus 1. You see, you draw the tree like that. Then you will finish it, you go back, then you'll see what's the sequence of that. And you will not miss it. Okay, I don't see any comments, so I assume that you are okay with this one. Yeah, go back and think about this. Yeah, how do we do it? So you can try something smaller, maybe the first 5 elements or the last 5 elements. See whether you can do it yourself. Okay, maybe 10 elements a little bit longer. You do the last 5 or the first 5 and check whether your understanding is correct. Yeah. Okay. So the complexity of this one, how do we do it? So you see that the complexity is basically you subdivide into 2 parts, right? You have n elements, you subdivide into n plus n divided by 2 and n divided by 2. So basically you have 10, you subdivide into 5 plus 5. So you have 2 equal parts, yeah, so but you have 2 of them. Each group is smaller. And also you need to use the base case to give you some initial condition. Yeah, the initial condition here, if I and j are equal, you do with the very minimum. So don't put it as 0. Sometimes you'll be a little bit surprised you see the result. Put it as 1. Yeah, so you need to do the comparison of I and j, you do it. So we assume that the job is quite minimum. We assume that we use 1 unit of time to do it. Okay, so with this understanding, so you look at it, at the very beginning, you have n elements. You have n elements here. So we divide it into 2 parts here. Each one will be n over 2. But you have the left-hand side, 5 elements. The right-hand side, 5 elements. So you have 2 groups of that. And then at the end, you have to merge them together. when you merge them together, you do it one by one. You look at these two elements. Which one is smaller? You put it there. Then you do it. If you have n elements, actually you will do n-1 comparison or n comparison. So we can say that is proportional to n. So each one you need c seconds, c unit of time to do it. So are you okay with this line here? You divide into two parts. So you can imagine that you have 10 elements here. So you chop it into two parts. The first one is 5 elements here. On the left-hand side, the right-hand side, you have 5 elements. So that's why you have the 2 here. Okay. Then once you sort the left 5 elements, the right 5 elements, you have to merge them together. When you merge them together, you have to look at it, compare the element one by one, right? So it's proportional to n, or you may say that it's n-1 or whatever. But it's proportional to n. You will see that n and n-1 are the same, right? You are talking about n very big, you are 1 million. Yeah. So 1 million minus 1. It's 1 million. See? So we'll use this one here. Then you use the backward substitution, right? The backward substitution, I don't know why you cannot understand it. But basically using this particular one here, put it inside the brackets here. So 2 will be 2, t will be t. This one here, the number of elements here, you subdivide into 2. So is n divided by 2 by 2. So it's 2 squared. And this c is c n here, but n is n over 2. Wow. Wow. What do they do? Upstairs or downstairs or outside? Ask them to come in. Yeah, don't lock the door. Yeah. Okay, so you see that this is called backward substitution. So this one, to you is very simple, but when you apply this one to this kind of question, you don't know how to do it. Ask the guy to stop. Outside, right? You go over and ask him, yeah. You are strong, right? You are bigger than the guy. Yeah? Don't hit the door, yeah. Oh, yeah. Yeah, so you see that, huh? Yeah, you are one statement better than us here. Okay. You look at it. This one here, 2 and 2, you cancel out, it will be Cn. This Cn plus this Cn will be 2Cn, right? So now you are not very sure, you can do one more time of the backward substitution. Then you will see that if this is the one here is 2, then this is 2. If this one is 3, then this one is 3. If this is k, then this is k lah, huh? Or I. If this is I, then this is I, this is I. Okay or not? Yeah. So the standard way to solve this kind of problem is, because we want to use the initial condition to make this one to be 1. So we have to assume that n is equal to 2 to the power I, such that inside the parenthesis is equal to 1, right? So once we do it, so this one become 1. T of 1 is 1. 2 to the power I is n. We assume that n is equal to 2 to the power I. Then you still have ICN. Cn is here. What's I? I is log n, right? Because I is you create by you. In the problem is we use n only. So you have to convert everything to n. Then you look at it. This one is n, this one is n log n. Which one is bigger? The second one is bigger. So if you don't agree that this is equal to 1, you set it equal to 0, then this term is 0. Will not affect the end result, but it's good to assume that you have used some time to do the comparison, to put it as 1. Right? Because if this one is equal to 0, this one is a little bit arbitrary. But I checked a few books, they all use 1. The 2 textbooks we are using, they all use this one as 1. But if even you say that, oh yeah, we don't need to do anything, you merge sort, right? Base case, you put it as 0, then this one will become 0. The first term will become 0. So compared to the second term, will be much smaller. Then the second term will be the dominant term. This is the answer. Okay or not? So backward substitution. Yeah. Okay. You have to try it. You don't look at it and fast forward very fast. Oh yeah, I know that. Just substitute into that. Yeah, I have done so many linear algebra problem. This one should not be difficult for me, but it doesn't work. Right? So you have to try a few of them. Don't just look at my algo, yeah, my working. Yeah. You have to look at your working. Okay or not? So any comment on that? Okay. So we go to the next one. Next one is quite interesting. Yeah, you have an array. The array is A. Array is A. It has 2 sub arrays. 2. The first one is M. The second one is N. So the total number of elements in A is M plus N. Can you see that? M plus N. Because the first group is M. The second group is N. You add them together is M plus N. So you see that merge sort. When you merge them together, you have some subsidiary array to help you. You cannot just do it like that. This one is smaller than this one, then you put it here. But where do we put, right? We don't have space to put it, right? So we need to have a so-called a helper to help us to do it. Okay, so we need to have another array called B to help us. But this time the array B is the minimum of M and N. So if this one is 10, this one is 100 elements, right? So this one is only 10. You see that is the minimum of these two, M and N. So how do we do it? Think about that. How do we do it? Because the problem is this merge sort. The merge sort, you cannot do it in place, what we call. You cannot just here and then put it there and here, put it there inside this array A. You need to have an extra array to help you to do it. This extra array is, so if this one is the same as A, the size is M plus N, then we are very happy, very easy to do it. No difficulty. But now this guy is small guy. Only have the smaller of M or N, right? So how do we do it? Any questions? Any suggestions? So you have to understand it. We have two subarrays. Each one is sorted in good position. Yeah, just like your merge sort. You group it into two parts, and each one is in correct positions, right? But the whole thing is not. Then we are required to do the sorting. when we do the sorting, merge sort has a problem is not in place, what we call on the spot. You must get some helper, some extra array to help you. And this time the extra array is very small, the minimum of these two. So how do we do it? Okay, let's look at the simple case first. Okay, any comments here? Huh? Okay, so let's look at the simple case. Then, so you see that if m is less than n, the first case, m is small, 10, n is 100, very big, right? So this guy b should be 10 only, right? So you move everything to here. B will be here. So this B is sorted. This one is also sorted, right? Then you merge them together and put it here. Put it here. It should be okay. That is the simplest case. Okay or not? If the other way, if n is smaller, you have 100 at the front and 10 at the end. So what should we do? So we can do it like this. We move the smaller one to there. We move the smaller one. I use a lot of time to draw it. You have to understand it. Yeah. This n here, you move to here. So this green one should be okay, right? But this one, what should we do? Our merge is not merge from the biggest to the smallest. Our algo is from the smaller up to the bigger, the largest one, right? So it will not fit our algo, the merge, right? Say to write another algo. Of course, you can write another algo, right? But you have one program to merge, right? One is from small to big, the other one from big to small. Not a very good one. So what should we do? We can do it like that. First, we move to here. The yellow part, you have to shift to the end. Why do we do it like that? Because you compare to the first case and the second case, they are exactly the same, right? So now we have used one merge, then merge all of them together. Okay or not? So this one cannot be easier, right? I can explain this one to the primary school student. They still can understand, right? Okay or not? Now, so the problem is when you shift, don't be too smart to shift this one to here, then the second one to here, and so on. Don't do like this. Shift it like this. The N1 shift to the N. The second N go to the second N here. You do it from the back to the front, Okay. Because this is small, this is 100, this one is 10. You cannot just put it here, no space for you, right? Because this is 100 elements, say this one is 10 elements. So this number one, we'll put it at 101. It's not correct, right? Not correct. So you have to put the last one, the 100, put it at 110, put it here. Then 99, put it at 109 here. Do it like that, then you have space. So the sequence is important. Understand? So better you use the big one, shift to here, then the second big one, put it here, and so on. Yeah, so you understand what I mean now. You cannot just say that put this one here. Put this one because no space. This one is occupied by someone here. So may not be cool, may not be enough space to hold this one. So you cannot shift this one to here. Cannot. At that time, someone has occupied this particular element, right? Particular cell. Okay, so now once we have done that, then these two guys are the same, right? These two cases. Then we merge them together. Okay or not? The idea is very simple. Very simple. Okay, so now we have to use the pseudocode to do it. Now the pseudocode, we have to look at it. If m is less than n, we shift everything to b, right? The first part to b. If this is not true, then we shift the last part to b, and then shift this one by one from the end to the front to this particular one here. Okay. Any questions? I have done this one, but you have to spend some time on that. Yeah. So S will be the minimum of M and N. Yeah, because we don't know which one is smaller, right? So we have to create an array, which is called B. The size of this new array is S, because S is the minimum of M and N. Okay, so the first part, if M is less than N, well, what should you do? You shift the front part to B, A, the front part of A to B. So B will hold the first part of A. But this is okay because M is smaller than N. B should have enough space to do it. Else, if M is greater than N, the second case, you will need to shift, but you have to take care of the index. You shift it here, but once you shift here, you have to shift the yellow part to the end, right? To the end. So that will be this one here. For I equals M down to 1. So you do it from the end to the front. You cannot do it from 1 to M. You don't have space to do it. So you shift it here. So this one here, I don't go to the detail about the index. You have to look at the index. Okay. The idea I have explained to you. The details, you have to spend time on that. So you shift it there. Once you shift it, so what's the next one? Merge them together. All right. So on the next page, we'll merge them together. So we have 3 counters. The counter is Q. This one is Q. This one is P. This one is R. Okay. Because we have 3 counters, I don't know what to do. I don't find an easy way. So I draw it there. P is there. P will be here. Q will be there. So now we merge them together. When we merge them together, we compare the first element of this part and the first element of this part here. See which one is smaller. The smallest one, you put it at Q, right? So the idea is like that. So AQ will hold the AP if this guy is smaller. Once you do it, then P you have to update it because the first element has been used. So you have to update the P. If this one is smaller, then this one will shift to here. So AQ is equal to BR. Then R will be updated. So once you finish either one of them, then you update Q because Q, the first element has been shifted there, right? So you keep doing that. This while loop, then all the elements will be shifted, will be combined together. This is combiner. But This is a tricky part. So once you finish it, you may have some leftover, still have some leftover here. And you have some leftover here. There are two cases. You understand? You merge them together, right? You cannot just, wow, very good, use up at the same time, right? Maybe one group has more elements, you still have some leftover. So if this one, the leftover is here, no need to do anything. If the leftover is here, you use up this element first, and then you have some leftover here. You don't need to do anything. Because they are bigger than that, they are sorted, so this group is the correct position here. If this one you have some leftover, you have to transfer this one to the end, right? Transfer this one to the end. Okay, so while I is less than or equal to S, some leftover in B. So you have to transfer all this from B to A at the end. But the other case, you don't need to do anything. If the leftover is at here, you use up all the elements here, the leftover is here, then one no need to do anything. Think about that, think about that. Because all these are bigger guys, so they are supposed to be here. Okay or not? No need to do anything. You use some numerical value to help you to understand it. Maybe the first time you don't know what it is. Yeah. Because you have to merge them together, the first group, the leftover may be in either one of these two groups here. If downstairs you have some leftover, then you move it to here. So this is what we do. What we did here. If the leftover is here, you use up all the elements, then this one actually is in the correct position. No need to do anything. Think about that. I can help you half of them. Yeah, the other half you have to help yourself, right? Draw some diagram, draw some elements, and see what happens. Yeah. Okay or not? Yeah. So you know what to do. Yeah. Any questions? So you have to do your homework lah. It's not possible to 100% transfer to you. Yeah. I can transfer 50%, 60%. Yeah. The other 40% you have to grab it yourself. Because all these index are sometimes very tedious, right? You have to sit down and look at it, then you can convince yourself. I check it 2 times or 3 times, they are correct lah. Because if I just tell you the algo, you don't know what it is. Yeah. So I draw the diagram to help you a bit, so you understand it. Yeah. Any comment on that? Okay. Online students, any comments on this? Okay. So the online student, yeah. So you also need to understand it. Yeah. Sometimes I find that you just record it. You think that you have the link, then you have the whole world, and then when you review it, you do it very fast. Someone told you that, oh, I don't want to do it normal speed. I fast forward 2 times, sometimes 3 times. Oh, very happy. So they overlook some key points there. So make sure that you don't miss anything. Yeah. So you have your own habit, fine, but you cannot miss some key concepts. And also you have to do it yourself. You see, you look at my answer doesn't mean that you know the answer. Okay, no comments. We move on to the last one. How about that? Today, very happy, right? Only 4 questions. Yeah. Oh, so the complexity. So what's the complexity of this one? So the complexity of merge, right? Basically, you merge them together. The merge them together is proportional to the number of elements you have. Because when you merge them together, you do it one by one. You do one comparison, you settle one element. You do another comparison, you do another element, right? If you have 100 elements, you have to do it, the comparison 100 times or 99 times, right? You cannot make it half, make it 10, right? So be proportional to the number of elements you have. So you look at it, the first array, you have m elements, m. The second array, you have n elements, right? So you add them together, how many elements you have? M plus n, right? So the complexity can be roughly described as proportional to n plus m, right? Now it's very simple, right? You know that m is the number of elements in the first array, subarray of A. The second subarray has n elements. So the total number of elements in A is m plus n. And then you have to merge them together to be proportional to the number of elements in this array, right? So it's m plus n. I explained to you that it's very easy, but at the very beginning, you don't know what it is. Yeah. Because when you do the comparison, you do one comparison, you will settle one element. And how many elements you need to settle? Total is m plus n, right? So it should be proportional to that. Yes or no? Okay, yeah. So this concept is very simple, yeah. You look at it, the IRA, say that, oh, what's the complexity of merge? Should be n. You say if you have n element, if you have 100 elements proportional to 100, should be like that. Don't give n log n or all this n square, all this. No, proportional to the number of elements there. Okay or not? I should not tell them because next week they have the IRA. Yeah, I will deduct the marks from them. I go back to change it. Okay, so next one is called bubble sort. Now, bubble sort is very important. When I was a student, I studied bubble sort. It's not because bubble sort is good, bubble sort is bad. I always use as a kind of bottom line for comparison. We are better than bubble sort, that means we are good, right? We always, yeah. So you see that the complexity at the end, we look at the complexity. The complexity should be proportional to n squared. So it's very bad. So that's why merge sort is better n log n. Right? N squared, you see that if n is 10, n log n is you look at it, maybe only 20, 30, right? But n squared is 100. So this is a bad, always as a counter example. Okay, so merge sort is bubble sort is like that. Bubble sort. Okay, so for I equal to 1 up to n minus 1, you go from n down to I minus 1. You can try it, yeah. Okay, so you have to do the swap. The swap here, you have to exchange these two elements here. Okay, so we use an example to do it. So each round, we finish one, when I is equal to 1, we do it once. When we finish it, the smallest one will move to here, the first element. There's another bubble sort the other way. The largest element go to the end. They are equivalent. They are the same in terms of complexity. There are two ways how you change the I and J, all this. You can do it, find the smallest value, put it at the bottom. Or find the largest value, put it at the top, right? They are equivalent. No gain. And different books, they may have different algos. Yeah. So this one is find the smallest one and put it there. Now once you put it there, then you may not have 5 elements, right? Because you have found the smallest value, then you have left remaining 4 elements here. So the next one, when I is equal to 2, you have only 4 elements. So you find the smallest one, you put it here, the second element, right? Then the next round, you have 3 elements, right? And so on. Okay or not? Okay, let's see the details of that. So we are going to sort these 5 elements. Yeah. So what we do? So the first round is when I is equal to 1. So J will be from N up to I minus 1. So you have a few sub cases. So you check these 2, the last 2, because we do it from the N. N is here. So these 2, 23 and 20. 23 and 20. So we have to do the bubble sort to make the smaller one here, the bigger one here. So is this swap here. The swap is to look at these 2 only. The last 2 elements, put it there. Once you finish it, you take care of the 20, this element and this one, the number 3 and number 4. So you do the sorting, you do the swapping, then the 20 smaller, put it at the front, and 28, you put it here. So I highlight it because at each time you focus on only 2 elements. Yeah. So the next one, you come to here, you have 29 and 20. So the smaller one, put it here, the bigger one, put it here. Okay, so you finish it. Now you have the last one, 11 and 20. So you do it, the smallest one, 11, you put it here. The larger one, 20, you put it here. So you finish the first round when I is equal to 1. So at the end of this process here, you look at it, 11 is in the correct position. So basically the smallest one will go to the front. So now we have 4 elements, right? So we do this one again. Here, when I is equal to 2, when I equal to 2, we'll do it like this. We look at the last 2 elements. We do the sorting. We do the swap. Yeah, the smaller one put it here. The larger one we put it here. So every time we look at 2 elements, and then now we look at 29 and 23. The smallest one put it here. The bigger one put it here. So these 2 settle. Then we look at the next 2 elements here. So 20 and 23. So 20 is smaller, you put it here. 23 is bigger, you put it here. So at the end of the process here, these 4 elements here, the smallest one of these 4 elements, 20, is placed at the correct position. So previously 11 is correct, 20 is correct. Now we need to sort the other 3 elements. Okay or not? Next, when I is equal to 3, so you have only 3 elements here, right? So previously, so what's that? 29 and 28, right? So you do the comparison of that. 28 is placed before 29. So these two are settled. Now 23 and 28, you compare them together. The smallest one, put it here. 28, you put it here. So after this step here, 23 is correct. 23 is in correct position. So 11, 20, and 23 are in correct position. So still left with these two. All right. So you do the sorting. So 28 and 29, you sort it. The smallest one, put it here. Of course, this one here. So in this case, you have only 4 steps here. Because you have 5 elements, right? If you can sort 4 of them, the 5th must be correct, right? So no need to go to the 5th one. So okay, not yeah. So this one you have to know how to do it. If you read other books or you go to internet to look at it, they may give you another version of that. So basically the same. They find the largest one, put it at the top, and then you have not 5 elements, become 4 elements. You find the biggest one and put it at the top. You keep doing that. Then at the end, this is also correct. Yeah. Different way to do it. Yeah. There's no so-called a single way to do it. Multi possible way to do it. But this one is very slow. You see that because you look at the one adjacent one next to you. Yeah, look bigger than me. Okay, if not, then exchange, right? Position, something like that. Very slow. And after a few rounds, you will only find the smallest one or the biggest one, and you put it in the right place. So any comment on that? So this one has been in the exam. Give you 5 elements here. Use double sort to sort it. You know how to sort it, you know the end result, but the step you don't know. Because 5 elements, right? You know how to sort it, yeah. Even you don't know double sort, right? I look at it, they all know how to get the correct sequence, but the steps are not correct, yeah. Then one student put up their hands. Yeah. What's bubble sort? I say bubble sort has been introduced in your tutorial class. Which tutorial? I say that I cannot tell you. Yeah. In the exam hall. Like that, yeah. Okay. Yeah, so what's the complexity of that? So how do we know that this is not good? Because merge sort, we have done that n log n, right? N log n. So if you want to be better than merge sort, so the big O should be smaller than n log n. So how do we know this one here? So you look at it, you have 2 for loop here. The first for and the second for here. So this is the key. You have to understand it. This is the key. This 2 for loop here is a summation. Is the summation, right? So here the complexity is, the worst case is swap these 2 elements, right? We say that one or C, we call it C, C units of time to do one swapping. Okay, so now you know how to do it, right? You use 2 summation, one for this for loop, the other one this one. Inside you do the comparison, and then you have to do the so-called swapping. So we assume that this one is C unit of time. So with this one, we can see that. So this one is here. You have the first summation, you have the second summation. Although the second summation is from n up to I plus 1, right? You cannot do it like that. You have to put it from I plus 1 up to n. They are the same. From what, if you do the summation from 1, 2, 3, 4, 5, is the same as 5 plus 4 plus 3 plus 2 plus 1. Right? The same. So once you do it, so you see that. How do you find that C is a constant? So you can pull this one outside the summation and find out how many elements here is n minus I. Yeah, this one minus the last index minus the first index, you plus 1 to it, then you can see that this is the answer. From here to here, how to do it? You substitute the value lah. From if I is equal to 1, the first term is n minus 1. When I is equal to 2 is n plus 2. So basically is 5 plus 4 plus 3 plus 2 plus 1 from the top to the last one, right? It's the same as 1 plus 2 plus 3 plus 4 plus 5, right? So it's the same as this one. You can convince yourself. You substitute the value, then you see that for I, for different value of I. The first term is n minus 1. The second term, n minus 2. The third term, n minus 3. You just do it from high to low, right? So you can change it from low to high. This one, then use the formula, right? To do it, then this one here, you lower it. So you can see that. So how do we describe this one? Because you know that this one is n squared. This one is n, right? So n squared should be the dominant one. So we say that it's a big O of n squared, n squared. So compare with the previous case. This one not good, n squared, right? Previous one, merge sort, Merge sort is n log n, We have done that, n log n. This one is n squared. Which one is bigger? So this one is bigger, no good. We always learn that because it's no good. It's a counter example, Okay or not? Yes.
Instead of like proving with math, right? You put like in terms of words. So like let's say the first for loop, you say that because you're going through every single term by 1 to n. Then for the second for loop, you're going through every single term. So it's a nested loop. That's why it's n squared.
Wow, you understand it is okay lah. You see, but this one is, you know that this more complete
Because the mock test last time they asked us to actually like do words.
Yeah, I just tell you that is 30, 30, 40. Yeah, so that's all. The detail is here lah, So you know that the complexity is n squared. Because it must be n squared, because for the first loop you have n times, the second loop, the worst case, you have n minus 1 times. So multiply them together to be n squared.
Can I put that in the item before? Or must I show this?
Of course, this one you get the full mark, right? You want to get the discount, I give you discount. You know, I don't know. You see? Yeah, I'm not that smart. You see? You have to tell us, I'm not that smart guy. You see, you have to pity me. I have to mark yours. Not just you, many students, right? Some of them are very smart. I look at my answer is not as good as their answer. They have to admit that. But most of them are not as good as me. Okay or not? Any comments? Okay, online student, any additional comment before we finish this one, finish this section? So this one is quite interesting, yeah. So spend some time on that. Don't just look at it. You have to do it, try it, then it's yours. Oh, okay, we stop here. Thank you.